Okay, cool. So today we'll look into a couple of problems on segment tree and we will have a look on what lazy is. Okay. So before that, let's see this problem. Subarray sum queries. Let me give you this. Have a look and let me know if you are able to understand this question or not. Okay. So did you guys read the question and did you understand what it was?
Yeah, yeah.
Right, so we do have an array, okay, and some values of the array will be updated and you need to tell the maximum sub array sum in the array. Okay, so at least, like, are you able to think of that there is this segment tree because there is an
Yes.
update and you need to report
Yeah,
the sub
yeah.
array, right? The only problem is that, okay, update can be done easily, but what about maximum sub array? We kind of don't know from where to where it is, right? That's the problem. Okay, so let's deep dive into this problem. Okay, and it might take some time to explain, but yeah, let's see. Okay, so how does the structure look like in a segment tree? It's something like this, right? That we have something like this. Okay, okay. Now, like, instead of drawing many nodes, we will just focus on three nodes, and maybe it would be a little helpful for us. Okay, so let's say uh, the question is about finding the maximum subarray. Right now we don't know what are the information needed for us, so you know that the parent node takes the property of this and stores some information over here. Right now, first thing to identify is, like, okay, what the information we need to store here, what the information we need to store here, and what we will get from these children. So what do you think? Like, what shall we store here? I mean, in the leaf nodes. What do you think? Like, what information shall we store? The question is regarding the maximum sum. So, do you think, like, we should store maximum sum?
Yes, bro.
Okay. So, let's say this range is having L to R. Okay. And what will be this? L to mid
Mid.
and
Mid plus one,
mid
two,
plus
or
1 to R. Right. We do have this. Let's say we store the maximum sum here and here. Okay, let's say, like, we have something as some array, okay, of, let's say, length 3 and length something, length 3 or length 3, something like that. So somehow at this instant, let's say that we have the maximum sum of this array stored here, maximum sum of these arrays stored. Okay, let's say this is 0 to 3 and this is 4 to 6. So can I say this will be nothing but 0 to 6? If this is 0 to 3, if this is 4 to 6, can I say
Yes.
this node will store the information for 0 to 6? I can say that, right? So the
yeah,
say for this the answer is something as M1, and for this is M2. So what do you think? M1 is maximum sub of this range. M2 is maximum sub of this range. What do you think will be the answer of this? If this is if this for this array, if this is the max sum, if for this array m2 is the maximum sum, so for this node, can I say one of the answer will be, I mean, there is this chance.
Yes, max of yes.
So you kind of have to tell, right? I mean, that's what I
Yes,
asked.
yes, yes.
Okay. So max of m1 comma m2 is one possibility. Okay. Now assume that m1 is nothing but this one, and m2 is nothing but, let's say, maybe this one. Okay. There is this subarray. So do you think by considering m1 and m2, are we able to get the answer for length 0 to 6, or is there something we missed? What do you think?
Can you repeat the question, bro?
So what did we store? Max of m1 comma m2, right?
Yes.
So what is m1? M1 is the maximum subarray for L to mid. M2 is the
Mm.
maximum subarray from mid plus 1 to R. And we are
Mm.
saying that for L to R, the answer will be max of m1 comma m2. But
Mm.
the question is this enough? I mean, will the maximum sum will be nothing but max of m1 comma m2, or are we kind of ignored something?
Yeah. Sometimes after like combining, we might get
Yes,
max more than this, right? Other
exactly,
than this.
exactly. So there is a chance that there is some portion like this which can be maximum, correct?
Yes. Yes.
Now the thing is, you already considered this part.
Mm.
We already considered this part, but when
Mm.
we merge this two subarrays, there is a chance that this is a first subarray, this is a second subarray. Once we
Mm.
merge them, the array becomes like this. The initial answer was this one. I mean, for this part, the answer is this one. Let's say for this part, the answer is this one. But as soon as
Mm.
we merge, there is a chance that subarray can be this, the maximum subarray.
Yes.
Yeah.
So we kind of don't have this information, right?
Mm.
So how to keep track of that? Okay, so as soon as you see that we need something from here, we know we need to keep in our in our node structure, right?
Mm.
One thing we will obviously store is, for this range, what is the maximum sum. So first information is nothing but max sum, correct? This is for sure we need to store. Okay, second part is, do you guys see that whenever we join, there is some portion from here, there is some portion from here which is getting merged and giving me the sum,
Yes.
correct? So can I say for this node, max what, suffix sum? Can I say that this is nothing but suffix, right?
Mm.
And this is what?
Prefix.
Correct. So the one option is, in order to get maximum sum of the merged node, will be nothing but, okay, max of m1 comma m2 comma what, max suffix sum plus max prefix sum, right? Do you guys agree till this point? Quick yes if you agree.
Max suffix sum means after finding the max remaining elements, right?
Max means this part, man, this part. Okay, this is the small subarray, right? This is the first part, this is the second part.
Yeah.
So when you join together, this thing will get
Yes.
combined, right? Correct, this thing will get
Yeah.
combined, no? So if this thing will get
Yeah.
combined, so
Yeah.
if we somehow store the maximum of this and maximum of this is what the blue line is, right? The blue line is nothing but maximum suff plus maximum prefix. Can I say that? See, don't
Yes.
think
Yes.
how we will get this. Okay, first think about this portion. Blue portion is nothing but, when we combine these two subarrays together, it's nothing but this portion plus this portion only, right?
Yeah.
Okay. What do you think, Sas?
Yeah, correct, bro. Got it.
Okay. So can I say for this node, these are the only possibilities?
Can we have one other possibility like M1 can be in between of two things, right?
See, that's the part, right? If you're saying I said M1 is this part, but it
Mm,
would if it would have been other part, let's say this part, you would have considered this
mm,
one, right? I mean, this one will be come to your answer, no? So there are only two possibilities. Either the maximum can come from this part or from this part. See, maximum is what? We are very much sure that what's the maximum in this subarray. Okay. M1 can be
mm,
this part, or we don't know. Something. The only possibility which we missed is when we join these two subarrays. And when we join these two subarrays, there is only one possibility that this is the only one.
yeah.
Because other
Okay.
thing, however, it got covered by M1 or M2, right?
Yes, bro.
Make sense?
Understood. Yes.
Okay. So we kind of found out that in order to store the maximum sum for a larger range is nothing but the maximum which is coming from the left range, the maximum which is coming from the right range, or when we join them together, what's the maximum suffix from left portion and what's the maximum prefix which is coming from the right portion. Now, is this fine? Is this understandable till here? Like how to
Yes, yes.
get the max? Okay.
Yeah.
Yes.
Okay. So for this large node L2R, we kind of found out what is the maximum, right?
Mm,
But did we see that we also need maximum suffix and maximum prefix also,
mm,
right? So for this node also I need to store the same information, right? Maximum suffix and maximum prefix.
yes.
We
Yes.
have these two subarrays. Okay, we combine these two form a larger subarray. Now for this larger subarray also, it might also merge with some other node which we don't know. Okay, so for every node we need to store what's the maximum prefix, what's the maximum suffix. Now try to think, how can we get the maximum prefix of this larger subarray from these smaller two subarrays.
Doc, can you write like numbers examples? It would be easier.
See, what I'm saying is, if I write numbers, okay, let's say we have 3, okay, 3, 1, minus 4, minus 6, okay, 23, minus 10, minus 12. These are the small subarrays, Sam. Okay.
Yes,
When
yes.
we
Yeah.
merge it, it is nothing but this only, right? I mean, same numbers, correct? This is the larger subarray.
Yeah.
Now for this also we need to
Yeah.
store what's the maximum prefix sum and what's the maximum suffix sum.
Yes.
So how can we derive it from the smaller two subarrays? Because a parent node's answer will all in general will be derived from child answers only, right? So we know
Yes.
for this one what we know. We know maximum sum, which is M1. We know prefix, we know suffix. For this also we know M2, P2, S2. P1 is what? What is P1 for this? What is P1?
0.
Array 4, no. This maximum prefix sum, man.
Like that would be a max. Okay, okay. Prefix sum. Yeah. Okay.
What's the maximum suffix sum?
Minus 10. Minus 4.
Minus 4. This entire. Correct. So you understood the concept, right? Like, maximum prefix is this, maximum suffix is this. Maximum prefix is this, maximum suffix might be this, right? So when you merge these two smaller subarrays, what will be the maximum prefix
Bro,
of
what would be the M1 then in that case? Both maximum of both.
M1?
Hmm.
M1 is for this subarray, right? This smaller subarray, no?
A complete like it would be like taking maximum of P1 or S1.
Can you repeat again?
Like M1 is it maximum of P1 and S1? I'm asking.
No, man. What is M1 meaning? First, you tell me that.
Max of subarray.
Maximum
It's 4.
subarray. Assume that
Yeah.
you already know it. Assume that you already know it. Okay.
Yeah.
So this is 4. Correct?
Yeah.
This is 4.
4.
This is minus how much? Minus 6, right?
Yes. Minus 10.
Hmm.
4. Yes.
What about this? M2 is 23.
Correct.
P2 is 23. S2 is
23. This is
23
my
minus 1.
sorry.
1, right?
Yes.
So what I am asking is, for each smaller node, you have M1, P1, S1, M2, P2, S2. We
Yes.
need to
Hmm.
find
Yeah.
M, P, S for this larger array. Okay. So
Okay.
we kind of derived M, right? M is what? Max of?
Hmm.
Max M1 and M2.
Uh-huh.
S1 plus S2.
P2, no? Not S2. P2, right? This is S1.
Yeah. Sorry. Yeah.
Okay.
Correct.
Now we need P also, no? So what is P? That is maximum prefix of this. How can we find it from the child? So can I say,
One of the possibilities
uh-huh,
is P1
exactly,
and P1 plus S1.
P1 plus P1 plus,
S1
okay,
and P1 plus S1 plus P2 it can be.
yeah. So as you're on the right track, but this needs to be changed a little. Okay, you're on the right track. See, you for this example, it might be P1 plus S1 plus P2. Okay, but
Hmm.
like S1 is what? S1 is the maximum suffix sum, right? Correct. So
Yes.
in this example, what happened was like somehow this became minus and all. But
Hmm.
can I say when I merged them together, okay? Again, let me redraw again, okay? When I merged them together, okay? This is P1, this is P2, okay? So when I merge them together, the answer can be for the larger node either with this P1 or this
Hmm.
entire, correct? Entire means this part
Okay.
and maximum prefix of this. Make sense?
Yes.
Sam, did you understand?
Yeah. Complete left plus P2,
Yes.
right?
So what did you just say now? Complete?
I mean, smaller area of left one, like
Correct.
for P1.
So complete means, can I say it is total sum? Total sum of this
Yes.
one, right?
Yeah.
So P is nothing but max of P1 comma total sum of left plus, can I say this?
Yes.
This total sum plus the maximum of this portion. Okay. One possibility is sure that we were,
Bro, will there be any case?
yeah, go ahead.
Will there be any case like only being prefix sum as total sum without P2?
This P2,
Only with yes, like only total sum of left. That would
there
be complete prefix from.
there might be a chance, right, Sam? We don't know. We kind of don't know.
All negative numbers case.
Like what I mean is without adding P2, bro. Like only total sum.
See, if that was the case, okay. So in that case, what you are saying is total sum is positive, P2 is negative, right?
Yes, yes, yeah.
So in that case, if this is positive, P1 also will be positive only. What is P1? Maximum prefix sum. If total sum is positive, P1 is also nothing but total sum only, right? In that case.
Okay. Yeah,
Understood?
yeah.
Understood?
Yes, yes. Yeah, got it.
Yeah. Okay. So if P2 was negative, total sum plus P2 will become, I mean, less value. But somehow, what's happening is if you are saying that total sum is a larger value, then
Mm.
P1 will also occupy entirely because P1 is what? Max prefix.
Yeah, okay, got it.
This holds true every time. Okay. So
Yeah.
for the larger array, we kind of derived P. What about S, which is maximum suffix sum? Can you try? Similar to this one only, right? Just in the reverse way.
Yes.
So what should be?
Yes, 2.
Uh-huh.
S1 plus right.
Yes,
S1.
total sum of.
Yes. Correct. Total sum of.
Yeah.
That's all. Oh yeah. This it. This is. And somehow, can you see this also? Total sum. So we maintained maximum, prefix, suffix. Since we are taking the total sum also from the neighbor nodes, can I say I need to maintain one more information, which is total sum?
Yes.
So what will be total sum? It's very easy. Total sum of larger node, this larger node is nothing but total sum of this only, right? Because they are independent.
Yes, left and right.
Yeah.
Hmm.
So total left plus,
Total right.
and if you see, we have derived all the parameters from our child nodes. So if this is done, can I say we are done with the question? Because
Yes.
done everything right. Okay.
Bro, if you don't mind, can you explain by taking that sample example?
Where is it? Okay.
Yeah.
1, 2, minus 3, 5, minus 1. 1,
Yes.
just remember that. 1, 2, what's minus?
Minus 3, 5 minus 1.
5 minus 1.
Okay. So we know that it's a 0 to 4, right? So there is a big node from 0 to 4.
4.
It will divide
Mm.
into
2. 0 to 2.
okay.
3 to 4. 0 to 1. 2 to 2.
Uh, okay. So we have this. So is it fine? I mean, is the structure clear? What is the structure clear?
Yeah.
Yes, bro.
Chalo.
Yes,
So
yes.
we have 1, 2, minus 3, 5, minus 1. Okay. So for
Leaf
this,
notes.
yeah, we will store all the information. Okay. For can you guys say
Mm.
me for what this is singular? I mean for the single array element, the maximum sum, the total
Mm.
sum, the maximum prefix, maximum suffix will be same because this is a single element.
Yes.
Correct.
So what
Yes, same as element.
so what is zeroth element? 1. So can I say
Yes.
What about this?
2, 2, 2, 2.
Okay, so the structure is nothing but maxsum, max prefix,
Mm.
max
Max
suffix,
suffix
and total sum.
total sum.
Okay, up for 0 1, for 0 1, the answer is nothing but max sum of this or max sum of this, comma, maximum, maximum prefix plus maximum suffix, right? Can I say that?
Mm.
So
Yes,
can I
yes,
say the answer is 3? Maximum sum for 0 to 1 is 3.
yes.
Understood? Or any doubt?
Yeah, I got it.
What about you?
Bro, we should take max of both or some, right?
This is the formula,
From
right? M1 comma M2 comma S1.
Okay, okay. Okay, S1 plus P1. Yes, yes, yeah.
So what is S1 of this 1? What is
1.
P1? 2. So
Yeah, yeah,
1 plus 2 is 3 max. So 1 comma 2 comma 3 is max is 3. Okay.
yeah.
Chalo. Next is maximum prefix.
Prefix.
So maximum prefix is nothing but maximum prefix of this or the total sum plus maximum prefix of this one. Correct?
Yes,
So when
yeah.
I say the answer is
3.
mm.
this also will be 3 only probably.
Mm.
Yeah.
And this
Total
also.
also 3. Yes.
What about this 2 to 2? Okay, minus 3.
Mm.
Okay, is it fine?
Mm.
It's fine.
Yes.
Yes.
Okay. Chalo, let's.
Bhaya masa.
This is interesting. 0 to 2. Okay, 0 to 2 is nothing but first let's try to find the maximum sum. So maximum sum can be nothing but maximum sum of this one. Either it is 3
Mm.
or it is minus 3 or
Mm.
Sum of.
yes, or maximum suffix sum. Okay, maximum suffix sum of this part, maximum prefix sum of. So I guess
Okay.
Is
3
3.
will be the part, right?
Yeah.
Mm. Mm.
Okay. What about maximum prefix? Maximum prefix is nothing but maximum prefix of this, comma,
Mm.
total sum of this and uh,
P2.
what which one we are dealing with? Maximum prefix, right? Yeah. So
Yeah.
maximum prefix of this plus total plus this. So again, can I say it's
3.
similarly? What about this one? Now this is maximum suffix. Maximum suffix is nothing but maximum suffix of this, correct? Minus 3 or
Mm.
total sum plus
Mm.
uh, total sum plus
Maximum suffix.
maximum suffix, which is 3. So in
Mm.
this case,
0.
can I say it is 0?
Yes.
Yes.
Okay. And this is very straightforward.
0.
Okay. So,
Mm.
like, is it okay till here or shall we?
Yeah. Understood.
Okay, cool. So, shall we go to code or
Yeah. Yes, yes.
you can write it? Okay, I'm changing this only. So, since I have sent it yesterday, I'm just changing it. Max sum query, correct?
Yeah.
Chalo. So, let's go to node structure first. So, node structure mein what we need? Int maxsum, int max resum, int max suffix sum, int max. Is it fine?
Yeah.
Yes. Yes.
Okay, so we will initialize a empty constructor and we will initialize a Okay. Like, is there any shortcut to generate? Okay, let me write it.
Mm.
Getters.
Sorry,
Nothing.
this dot max sum. If it was an IntelliJ, I guess it would be little easy. But okay. This dot max prefix sum. This dot max suffix sum. This dot max total sum is max. Okay. So I guess this we shall write it as total sum, right? There is no max stuff over here. This dot total sum. So is the structure clear? I mean node structure what we stored.
Yes.
Okay. Chalo, done. Once done, we will. So shall we go to merge?
Yeah.
Okay. So node equals to node. So node dot maxsum is nothing but math dot max of. Can you guys tell me? Child one dot
Maximum.
child one dot. Okay, let me write like this. Child one dot maxsum. Child two dot prefix sum. Now the one which you are saying. Okay. What do you think? Is this correct?
Yeah.
Yes.
Okay. Child one का max suffix, child two का max prefix और child one का max, child two का max. Okay.
Mm.
Node dot max presum is nothing but math dot max of either it will be child one dot max presum, okay,
Mm.
comma, uh,
Child one plus child total sum.
child one dot total sum plus child two plus. Is this correct?
Yeah.
Yes.
Node dot max suffix sum is nothing but math dot max of. What can be the value for this? Go ahead and tell me.
Child one dot.
Child one dot.
Child two dot max.
Correct. What do you say?
Yes.
Child 2 का max suffix, comma, child 2 का total sum plus child 1 का max sum. And the last,
Mm.
which is very easy, is what do you say? This is pretty easy, right?
Yes. Yes.
So is our merge done?
Yes.
Yeah.
Yes, it is done. Okay, chalo. Let's go to build tree. Okay. So build tree में क्या करना है? We will go here. It's very easy,
Mm.
right? Tree of index is nothing but, since we know for the base cases all the values will
Values same.
be same, so it will be nothing but
L A of yeah. A of L. A of L. A of.
uh,
Mm.
okay.
Yeah.
And I am not touching anything because we know that it will give us the correct merge. Okay.
Mm.
Now see, the reason I taught you like this is because if you would have written here the merge logic, you should change this line. But now since this is inside the merge logic, we did not change anything over here.
And reusability purpose also, right? We are using it in update and build.
Correct. ठीक है. तो next क्या है? Update है, right? So they said that you can even update also, no?
Mm.
Mm.
Don't do anything. What to do? Just copy, paste इसमें, remove everything from here.
Correct.
Okay, straightforward, no change here.
Mm.
Hmm.
Up query. ठीक है. So do we need a query for this case? What do you say?
No.
Yes, not required because the root node will store the answer, right, every time.
Mm.
So Sam, did you understand?
No, man.
See, can I say the root node will always store the maximum sum from 0 to 4?
Yes.
So we can directly get it from here only, no? Why to do any iteration?
Okay, okay. To get like where it is possible,
Yes.
no need of checking that.
Yes.
Okay, okay.
Okay. And ये सब फालतू का, let's remove it. Let's see what they have given us. NQ, okay, and these are queries. Okay, so after each query we need to tell the stuff. So
Mm.
NQ हो गया, A हो गया, segment tree done, ये while loop. Let's remove this while loop. Okay, so what they said, they will give you two integers. The value at position K becomes X. Okay, now can you see this is one based indexing? I mean, index, this is 2 means ours index 1.
Mm-hmm.
So int index int value. Okay, index minus minus s dot update of 1 comma, is it fine? Same update function we will call it. Okay, once done, system dot out dot print, is it println or print ln? Okay, can you tell me this? What should I write here? The root node.
Yes.
So s dot tree of 1 or 0?
0.
0 or 1?
0 root node.
Dot, is it
Not
Max.
max.
okay? Shall we run then?
Yeah.
Yes.
Null pointer exception, 22 line. So it should be 0 or something else now.
Not 0. It should be 1, I guess.
Because we are starting, see, yesterday only I taught you, right, that index is what? Then unique identifier for the tree. And always we are starting from 1, no? So why it will be 0? It will be 1, right? What, understood, Sam?
Then why we are index minus minus for?
ये वाला तो ये इंडेक्स के लिए है. अरे see,
That queries one.
this is the queries. This is
Yeah.
one based indexing. This 2 means this 2. And if we write like this, ours is this 2, right?
Yes.
0 based. So we have to change it to 1 based, no?
Okay.
Hey, what, man? It should be. ये -2 कहाँ से? What is this -2 by the way?
You copied 9 and the output also, bro.
Uh-huh.
9 and
No, it's not like that. I should press enter. Yeah. Okay, let me do like this, okay? Just to be on clear path. We will not paste it. We will give it manually, okay? So it's, remember this, 5
3.
5 3. Yeah, tell me some Sahas. 1, 2, minus 3, 5, minus 1.
1, 2, minus 3,
Hmm?
5, minus 1,
And
2, 2, 6.
correct? Did we get 9?
Yes, yes.
3, comma?
1. Yes. 2 minus.
Okay.
Okay.
So are we getting the perfect answer?
Yes.
Yeah. So this is what we have done. Okay. So with each query, so what we have learned probably is like what structure. I mean, yesterday we have only kept one property or might be two at max, but now you see we maintain few properties.
Mm.
Each of the property was playing a responsibility in order to derive answer. Right. So the thing in segmentary is like the medium level questions or little towards easy medium. It's about deriving these properties and we can do it. Okay. So is this code clear?
Yes, yes.
So Sam,
Yeah, clear.
this one did you understand?
Yes, bro.
Sure, right? This index is what index? The update index. And our tree is starting always from one, right? So one.
Okay.
Bro, what if we start from 0 is dot update?
This one.
Yeah.
So why we started from one? It's very simple. This is index one, right? So this
Mm.
will have an index. How much? This one.
2,
This one.
3,
If you keep zero, what will be this value?
1.
Eh? One. Zero.
2 into node plus 1. Okay, okay. Sorry, sorry. Yeah, I got it, got it.
Yeah, you can keep like this: two into node plus one and two into node plus two. You can.
Mm.
I mean, up to you,
Yeah.
but generally we follow one base two.
Okay, okay.
Okay. So, is anyone here?
Manan joined.
Hey, Manan.
Hello.
Yeah. So probably like you should see the recording. Okay.
Yes.
Subarray some queries. The maximum subarray after each.
कड़ान
I mean, it's not Kadan basically, but yeah, like
हाँ मतलब कड़ान्स क्वेश्चन यू आर टेलिंग विल डू दिस या
तो थोड़ा मर्ज लॉजिक अच्छा दिख रहा है इस बार. Okay. चलो. So let's go through another question. Yeah. This question has appeared in Leet Code 4th.
फोर्थ
Yeah.
Okay, can you paste that question?
This one.
Mm.
It is increasing if each element is greater. Okay, so this is okay. I mean, let's not take this. Okay, I mean, this is a little advanced variation on this. Okay, I will give you a easy problem to solve. Okay,
Mm.
so same question. I mean, instead of you can modify the array using choose an array element, increase the value. It asks when you consider sub array from position. What is the yeah? So can you see this 2, 10, 4, 2, 5?
Mm.
So the question is okay 2, 10, 4, 2, 5. So let's say you are given this array. What you need to do is you need to make this array non-increasing. Non-increasing or non-decreasing? Yeah. An array is increasing if each element is greater than or equals to with the previous element. Okay. So what you have to do is given an array for you, you can take any number and you can kind of increase it by plus one, plus one, plus one. You should tell what is the minimum number of operation required in order to make this array increasing. Okay. So this is a little harder variation. I mean harder in the sense that they are giving you queries. I am telling you for the entire array. Okay.
Okay.
So in this case, what can we do? Probably like we have 2, we have 10. We should increase it, right? We should increase it probably.
7 times
2, 7 times. 6 times, no? 6 times.
was greater or equals to
Yes.
then 6 times
ये वाला,
8.
8.
here is the catch, it's not 8. I mean, become 10, you have increased 6. Think of this perfectly, because what's the question? The question is, you can modify the choose an array element. Oh, it's only a single array element. Okay. Then, okay, let's not take this question. The same question I am asking you,
Mm.
you can take any subarray and increase the value +1. Okay? Not single element. If you are talking about single element, it's obviously 8. But I
Mm.
am saying you that you can consider subarrays and increase everything by 1.
Okay, in that case, 2.
So when you increased it for 6 times, you will also take this also.
Mm.
तो कितना हो जाएगा? So it will become 8, right? At that.
Yes, yes.
So
Mm.
now you only need how many times?
2.
So this will become 10 with 8 operations. Correct? Sorry,
Yes.
2 operations.
2 operations.
Mm.
Because at the same time you increased 2 plus 6 plus 6, it became 10, it became plus 8, and you did plus 2. What
Mm.
about this?
3.
No, it's 0.
Taking 4 to 5 subarray complete.
No,
Uh,
no. So, like,
it might
how?
be less probably, yeah, but yeah, let's assume. I mean, I am also not sure, we will manipulate it. Tell me, what are your thoughts on this?
What will be the subarray? Like, how
Okay, so
long it should be?
can we see that 2, 10, 4 to 5 is the one? This is one, right?
Yes.
So 2 and 10 is okay. Can we
Mm.
say I will increase this to 5 times? If I increase this to 5 times, it will become 9,
9.
it will become 7, it will
Mm.
become 10.
Mm.
Can I increment this one time?
Mm.
If I increment this one time, it will become this. And can I
Mm.
increment this 2 times? It will become 10 again.
Mm.
So the
Yeah.
answer was 5 plus 1 plus 2. So in 8 operations, you were able to do this.
2.
So did you understand, guys? Everyone? In 8
Yeah,
operations,
Yes.
we were able to do
but
it. So how can we do that?
so we are subtracting highest value minus
Mm-hmm.
highest value among all remaining sub.
Uh, yes, kind of. So would you like to give it a try? Because this has a very good trick if you see. I mean, I can tell it now, but I think that you can have some visualization, right? That okay, this has to be increased for 6 times for sure.
Mm. Mm.
What about this? How many times it should be increased? So the number of times you increased is nothing but this is 6, this is 2, and you are done. Okay, chalo, let me tell you. Okay, I mean, why to think of. So what's the array we had? 2, 10.
2, 10, 4 to 5. 4 to 5.
When I am at here, I mean, we'll start from here, obviously. Okay. So 10 is greater than this. So are we good here? At this position, are we good?
Yes.
Yes.
Good.
Yes.
When we are at this position, are we good?
No.
No. So if I have to start, I have to definitely start a subarray from here for sure. One of the subarray should start from here is sure, correct? Now, how many times I need to increment 4 in order to reach 10?
6.
6 times.
So can I say the number of increments I will do is nothing but plus 6?
Yeah.
Mm.
So this 4 will become 10 at the last
10.
somehow. Okay.
Mm.
When I am here, when I am here, how many times I need to increment?
8.
8.
It's actually it's actually
8.
2.
it's actually 8, but the fact is, what if you see this little bit in a visual manner, it is 4, it is 2. Let's say you want to reach 10 here. This is 10. Can I combine this both and go 6 at a time? If I combine this both and go 6 at a time, this 4 will reach to 10, this 2 will reach to 8.
Yes.
So can I just say I just need more 2 operations,
Yes.
and this 2 operation is nothing but the difference between them.
Yeah.
Yes.
Fun fact, that's the fact,
Mm.
right? That I have kind of like, if I have to increase it somehow, why will I increase it individually? I will take them and I will increase it. So in this case, what we will do is, when we have a smaller element compared to left side, it's nothing but the answer is the difference of them. So in this case also, can you see the difference is 6, the difference is 2. Okay,
Yeah.
let's think about 5. Since 5 is greater than 2, okay, when you were increasing 2, you would have also made sure that 5 was also been increased, right? For sure.
Yes.
So that's it. So do you require any operation for 5
No.
to make it 10? No, because whenever you were doing for these elements, you would have also done it for 5. So plus 0, no operation. And if you see, the answer is plus 6 plus 2, which is nothing but 8.
Okay.
Okay, this is not a segmentary problem. I thought that's that problem and I kind of took it. But yeah, this is one version of that. Okay, an easier version. But this trick you should know it in order to solve problem. Clear?
Yes, bro.
So how the pseudocode will look like? This is something like this, right?
Start from first index.
Done with the answer, right? Last, print C. So is it fine? 4 is less than 10, so 10 minus 4, 10 minus 4 is 6. 2 is less than 4, so 4 minus 2 is 2. So 6 plus 2 is 8. Okay,
Okay.
clear?
Perfect. Yeah.
Yeah.
Okay, what man? Hero,
Can
solve.
you scroll little?
Understood or not?
Yeah.
Sagar?
Yeah.
Yeah, can you scroll little bit up? But for the 2 and 5, we will be getting as
Why will you get? When you are increasing 2,
Condition.
you would have already increased for 5, no?
yes,
Then if you are increasing it for 4, at that time you would have increased it for 2. But
correct.
when you are doing for 2, since 5 is greater, when you are doing for 2, you would have already made this very much clear that I will go, I mean, this will always be done. Unless
Yes.
2 gets cleared, 5, I mean, 2 reaches to a certain point, 5 is done. So
Hmm.
there is no need to add anything, because whenever you are doing for this subarray, 5 was actually done somehow.
Okay, can you scroll little bit down?
Okay, clear?
Yes, sir.
Yeah, this is not a segmentary problem. I
Yeah.
mean, I thought
Understood.
that's a segmentary one. I mean, that was this problem, but okay, let it be. Chalo.
Bro, what if we have after 5 3 suppose?
After five, if we have three,
3.
so in that case, there is this two addition, right, Sam?
Yes, yes.
So plus two will be addition. If you write it manually on the pen and paper, you will see there will be 10 operations now totally, because this is 4, this is 2, this is 5, this is 3. Okay, so one thing what
Okay.
you can do is, at the first, manually you can increase everything to 5. Correct?
Okay, okay.
Yeah.
Yeah.
This 4 will become 9, this will become 10, this is how much? 3 will become 8, this will become 7. Correct? Now, since this is already in the barrier, I mean this has already crossed, you have to deal this part separately and this part separately. So 5 was the initial operation. In order to make, I will increase these two together, so it will become 10, it will become 8,
Hmm.
it is one operation. This one I will take it separately, which is two operations. This one I will take it separately, which is two operation. So it is giving you 10. And since 5 minus 3 is 2, so 8 plus 2 was 10, so 10 is 10. I mean, it's matching. Okay,
Okay.
not clear?
Actually, like, can you go to that question?
Hmm.
When we are increasing 4, we will be increased 6 times, right?
That's was the part, right? So
Yes, yes. By that time, it will become 9.
who said, I mean, it's not like you will take this 4, you will take entirely this array first.
Yes, yes. By that time, like 3 will become 9, right?
No, 3
It's
will become 8 now. 5, this is 5 is the larger, no, in this.
okay.
अरे भैया, ये है, this is how much? This is 4,
Yeah.
this is how much?
2.
2, this is
5.
this is
Yeah.
3. First increment it plus 5. So if you take the entire array and do plus 5, this will become 10.
Yes.
This will become 8. This will become 7. This will become 9. Now
Bro, it's not loading at all. I think, is it issue for myself or?
Everyone.
I mean, I don't know. Like, I cannot do anything about my connection, guys. So you have to bear. And I feel there is a problem with OneNote only. Okay, so like, is it audible?
Yes,
They
yes.
are audible.
Okay, so I'm audible, right? So, Sam, if I do
Yes.
plus 5 every time, so is
Yeah,
this
got it, bro. Like, yes, yes. Like, 3, like, it should increased more than 10, right? That's the
yes.
reason. Yeah, okay.
So we have 10 here. Our barrier was 10, right? Earlier, like the highest limit was 10.
Yes, yes. Yes, now increased. We should increase that.
Correct. So
Yeah,
now,
got it.
yeah, that's it.